Yeah.
Cheese grater, sir.
Cheese grater. Good. Okay, vegetable grater, cheese grater. All of them are one and the same. Your physics grading element is also same as that of your cheese grater. What do you have in cheese grater? Equivalently spaced holes. What do holes do? Allow some part of the cheese to go through it. And what about the intermediate space between the these holes? Does not allow. And are these holes randomly placed? No, equally spaced. That's what, okay, your cheese grater is a two-dimensional grating element, and here you're talking about single dimension, or here also you can have two-dimensional grating. So what do you have in grating here? Okay, nothing but equally spaced transparent regions separated by opaque regions. Transparent, which allow light to go through, opaque regions which does not allow light to go through. So we have equally spaced transparent regions separated by opaque regions. That's what is your grating element. So the number of transparent regions you have will be the number of slits. So here the grating element is nothing but an N slit device. N slit device. So you have N slits. Okay. So you're making these N slits to four. Okay, N slits, and you're making a parallel beam of light ray, a parallel beam of light ray to incident on it. After incidenting, it may go directly in the direction of incidence, that is dotted lines, or it may take a different angle, theta. Now these are the okay, what do you say? Continuous lines, not dotted lines. Okay, continuous lines, arrow marks. So why should we consider only theta? Why not 2 theta or 3 theta? Theta is an arbitrary value. Okay, you can range from -90 to +90, whatever you want. Okay, so it's just an angle. Okay, so all the rays that are propagating in the direction of its incidence, that is dotted lines, will converge at P naught, and all the rays which are making an angle theta with its original direction will converge at P1. I want to know whether P1 is dark or bright. To know that, I need to know what is the total amplitude at P1 because of the superposition of all these N waves that are coming out from N slits. So that is what I will try to find out. And before that, let me suppose that if the total path difference, when the total path difference is N lambda, will get constructive interference. And between the first ray and the second ray, between the first ray and second ray, the path difference will be A plus B sine theta. A plus B sine theta. That is your small d sine theta. Okay, d is equal to A plus B. That is given, right? What is theta? Theta is the angle made by the rays with respect to their original direction. Okay, so if this path difference is equal to N lambda, you'll get constructive interference. If the path difference is 2n plus 1 lambda by 2, you'll get destructive interference. The path difference can be converted into phase difference. That is what is given as phi is equal to 2 pi by lambda d sine theta. Okay, the same thing is explained here. And we'll consider that each slit is giving out an intensity AR or amplitude AR, where AR is equal to A naught sin alpha by alpha. What is AR naught sin alpha by alpha? That which you have already calculated when you have only one single slit. A naught sin alpha by alpha is the energy coming out of the slit when you have only one slit. But how many slits you have? You have n slits. When you have n slits, then the total amplitude should be added vectorially, or the displacement should be added algebraically. In the previous discussion, we added vector. Okay, we have taken amplitudes and added vectorially. Now in this discussion, I'm taking displacements and add them algebraically. Okay. So the general wave equation of any wave will be y is equal to a e to the power of I omega t or plus or minus I omega t. Okay. we have n waves, which I consider as okay, y0, y1, y2, y3, so on, or y1, y2, y3, so on to yn, whatever may be the case. When you want the resultant displacement, as we have already studied from superposition principle, the resultant displacement is the sum of the displacement made by independent waves. So y is equal to sum of the displacements made by independent waves. What are those displacements? y0, y1, y2 are the displacement made by n waves. So to add them up together. Okay, that's what I will do here. Okay, so what do I have? The resultant displacement. Okay, here amplitude and rasa. Okay, that should be actually displacement. Okay, the resultant displacement can be expressed as, okay, this is first line, second line, third line, fourth line. Fourth line. Okay, I'm talking about the fourth line, right? The resultant displacement can be expressed as y is equal to a naught cos omega t plus a naught cos omega t plus delta plus a naught cos omega t plus 2 delta plus a naught cos omega t plus 3 delta plus so on, so on, so on. So where did you get these things from? Where did you get these things, sir? Just simple. Okay. Now delta is the phase difference between the first ray and the second ray. And between the first ray and the third ray, the phase difference will be 2 delta. Between the first ray and the fourth ray, the phase difference will be 3 delta. Between the first ray and the fifth ray, the phase difference will be 4 delta. I don't know whether you understood or not. Just once again, between any two adjacent rays coming out from two adjacent slits, the phase difference is okay given as phi here, but okay, instead of phi.
Yeah. But the 10 rupees tally sana hakto.
Okay. Instead of this phi, in this what do you say, derivation or whatever textbook, he is using it as delta. I'm trying to search for that symbol delta. Yeah, this is the thing, right? Okay, right. Okay, right. Okay. So this is the symbol that they are using. Okay, only just because I have to match with the symbol that is being used, I'm using it here. Okay, right. So the phase difference between two adjacent waves is delta. So between the first and second, delta. Between the first and third, 2 delta. Between the first and fourth, 3 delta. Between the first and nth, n minus 1 delta. That's how you will have phase differences between adjacent ones, right? So when that is the phase difference, what will be the expression for the wave? Okay, first one is y is equal to a cos omega t. Second one is y is equal to a cos omega t plus delta. Third one is y is equal to a cos omega t plus 2 delta. Y is equal to, okay, the next one and next one and next one. Okay, all right. So that's what you are seeing here. Okay, first wave y naught is a naught cos omega t. Second wave y1 is equal to a naught cos omega t plus delta. Okay, third wave a naught into cos omega t plus 2 delta, and so on, so on, so on. Okay, sir, then why did you take capital N, sir? Forget it. Okay, no problem. Capital N or capital N minus 1 are very, very close. So for very large values of n, you can skip it. Okay, so that way you can say, okay, let me say you can say that you have capital N plus 1 slits. Okay, it doesn't make a big difference, right? So this is how you have, okay, the superposition of n number of waves, superposition of n number of waves or n plus 1 number of waves. Okay, now cos omega t can be written as the real part of e to the power of I omega t. Okay, this is what I try to express here in this one. Okay, so general expression is y is equal to a to the power of I omega t. A to the power of I omega t is nothing but a cos omega t plus I sin omega t. Okay, now if you have another y1, then e to the power of a e to the power of I omega t plus delta. That is nothing but a cos omega t plus delta plus I sin omega t plus delta. Okay, or here phi, whatever it is. Okay, delta or phi. Like that, you will have y0, y1, y2, y3. These may be complex numbers, but the real part of y0 is a cos omega t, real part of y1 is a cos omega t plus delta, and real part of y2 will be a cos omega t plus 2 delta, and so on. Okay, so cos omega t's are taken as real parts of a0 e to the power of I omega t. Okay, and this you has 1, and when you have delta, this is e to the power of I delta plus, okay, 2 delta, this is e to the power of 2 delta, and so on, so on. Okay, now this is a geometrical progression term. If you look at this one, the one which is in brackets is a geometrical progression term with a multiplication factor of e to the power of I delta, with a multiplication factor of e to the power of I delta. Okay, so the sum of n terms of a geometrical progression is represented as 1 minus e to the power of, okay, you can write as 1 minus r to the power of n by 1 minus r. 1 minus r to the power of n by 1 minus r. Okay, when the geometrical progression is given as 1 plus r square plus r cube plus r to the power of 4, and so on, so on, so on. Okay, when you have that kind of a geometric progression, sum of those n terms is given as 1 minus r to the power of n by 1 minus r. Okay, what is r here? E to the power of I delta. So 1 minus e to the power of I delta whole to the power of n by 1 minus e to the power of I theta. Good. So this is the mathematics of it. Okay, because it is complex, I want to convert it into real value. Okay, or you can put it as, okay, what is the amplitude of this one? On amplitude of this expression, amplitude of expression is a0 into the a0 into e to the power of 1 minus e to the power of I n delta by 1 minus e to the power of I delta, and e to the power of I omega t will be the wave factor, Okay, so amplitude is nothing but a0 into 1 minus e to the power of I n delta by 1 minus I delta, right? So if I want intensity, square of the amplitude. See, we don't have any derivation. Okay, intensity distribution expression for n slits. Okay, what you do is you just draw this diagram. You draw this diagram and write this page, and there ends the matter. Okay, rather this page and the next page also. Okay, that's so simple. That's so simple. Okay, so this is intensity is a square. A square is nothing but square of this complex number. Now, square of this complex number, if it is to be made real, then please understand that you have to multiply it with complex conjugate. You have to multiply it with complex conjugate. Intensity is real, amplitude is complex. Intensity is real, amplitude is complex. So if you want to convert the complex part to the real part, you have to multiply the complex part with its complex conjugate. Right, so I is equal to a square, that is okay, multiplying the amplitude part with its complex conjugate. A naught is as such, okay, a naught square, and 1 plus e to the power of I n delta by 1 minus e to the power of minus I n delta. So what is its complex conjugate? 1, okay, plus, okay, sorry, 1 minus e to the power of minus I n delta and 1 minus e to the power of minus I delta. So wherever you have I, okay, you replace that I with minus I. There, okay, this is the expression. So upon simplifying this expression using your okay, definitions for cos and delta e to the power of I and delta minus e to the power of, okay, you remember that? Okay, cos theta and sin theta can also express in terms of I. Okay, cos theta is equal to e to the power of I theta plus e to the power of minus I theta by 2. Okay, that way you can express these terms in terms of cos and delta and cos delta. Okay, this expression is equal to a square into 1 minus cos and delta by 1 minus cos delta. Again, from the trigonometric expression, this 1 minus cosine delta can be written as okay, sine square n by 2, sine square n by 2 delta by sine square delta by 2. Okay, what is n delta? N delta is the total path difference between the first and the last. Okay, and okay, n delta is the total path difference between the first and the last. Okay, that you got it from this expression. Okay, and delta is nothing but 2 pi d sine theta by lambda. Okay, 2 pi by lambda into d sine theta is delta. So that's how you got n by 2 into delta is nothing but n into pi d sine theta by lambda. Okay, similarly, okay, sine square delta by 2 is pi d sine theta by lambda. Okay, this is the expression, right? Now here you can consider this n pi d sine theta lambda, all this is a constant. So this is a naught square sine square n gamma by sine square gamma. Okay, that's what we'll represent now. Already this a naught we have already seen. A naught is that is a, okay, this is again a naught sine alpha by alpha. Okay, so in place of a naught, okay, this is your I naught sine square alpha by alpha square, and this is your sine square expression and sine square pi d sine theta by lambda. Okay, in that way. Okay, same. Okay, in place of pi, okay, pi d sine theta by lambda, we'll take it as gamma. So this is your expression, intensity expression, right? So from this expression, this is the end of it. Actually, this is the end of it. Okay, you can just take this term taken from the previous, ante. Okay, substituting your value of a naught from this and you're okay taking this as gamma. Okay, you got this expression. Okay, gamma is equal to pi d sine theta by lambda, right? Okay, so what do you see here? Okay, when I asked, okay, what is the intensity for double slit? So it was 4 times of original one. Okay, when it is three slits, we said, okay, 9 times of it, right? But for n slits, when I asked for n slit, you said n square times of original. But are we getting it here? 5 seconds for it. Can you tell me that for n slits, intensity is n square times of the I naught value? Okay, when gamma is equal to 0 or alpha is equal to 0. For n slits, the total intensity is okay n square times I naught. Can you say that? 5 seconds for that. 5, 4, 3, 2, 1, 0. Anybody? Okay, might have a difficulty, but that will be solved here. See. Okay, when do you get principal maxima? When gamma is equal to 0, that is gamma is equal to plus or minus n pi, that is gamma is equal to 0, 1, 2, 3, 4, and so on, so on. Okay, when gamma, okay, under these conditions, what do we have? We have n gamma is equal to 0, that is what? Sin n gamma by gamma becomes indeterminate, right? But we have a mathematical bypass for this. That means a shortcut. That's what you call as L'Hospital's rule that you have learned in your intermediate. Okay, from that what do you get? Limit gamma tends to 0 or alpha tends to 0, sin n gamma by gamma whole square is equal to n square. So did we get it or not? So I is equal to n square times of I naught. So that's how you got the principal maxima to be n square times the intensity given by single slit. Okay, I don't know whether you people have understood or not. Okay, just check it. We did not do anything. Okay, this was the expression. Okay, let us start from this.